Good morning. Sorry for the late start. So I'll just go 10 minutes over if you need it. What I want to do today, I'll answer any questions you have for the test. Remember, the test is from, hi Nicole, is from 12 p.m. to 6 p.m. So I will open it at 12. And you have till 6 p.m. to finish it. Does anybody think they need more time? So it's going to be on bin, STS, and just the P hat part, or P, I'll call it P. Or let's say proportion, inference. Okay, so what I wanted to do was answer questions you have about proportion, but really get into the last two topics according to our formula sheet that I asked you to study with. We want to start looking at, I don't know, Juliana. We want to start looking at the inference on mu. Sorry, inference, about mu unknown, right? So mu unknown. And we're going to do confidence intervals, sample size estimation, and hypothesis testing for the mean. And then what's going to happen is I'm also going to take away the parameter sigma. So we start learning all about about the theory, right? Using given information on the parameters, what does the theory tell us about what to expect in the sample? But then what happens is I start taking away parameters and we use the sample results to estimate the parameter. And here, the same thing. Here we don't know mu, which we want to estimate, but we also don't know sigma. So we have to estimate that. So in place of the sigma that goes into the formulas as the standard deviation of the mean, of the variable, we are going to, the variable being the sample mean, then we replace it with S. And we're able to do it here, but there's a cost. We change distributions as a result. Because we use an estimator, in place of sigma, we use there's a new distribution that's derived, and I want to talk about the t-table as a result. So first of all, let me know if you have any questions about any of this material. I put some extra problems up on Moodle. Just because there wasn't too many on this topic, so I put it up in Moodle. And so now I want you to tell me if you need any if you have any questions about these topics on the test. So on the test could be anything from 1, 2, 3, or 4. Yeah, no, it's I'm just giving you more time because students feel just keep on adding more time, because I don't mind about the time. I just don't want to waste your time. Try, you know, yeah, I don't want to waste your time thinking that it's going to take longer. It's just going to be 10 questions. Again, 10 questions. And if you can't do it in, you know, should be able to do it in 6 hours, no problem. Or do your best. Okay, so practice to, let me see, should I open it? Unit 5. It's very interesting that it doesn't show my keyboard on there. It's pretty smart. Okay, so Unit 5. Why don't you use, okay, 2012. I'm not sure which question it is. Question 8. Okay. Okay, so for the continuity correction factor, I mention here that in this part, I say keep in mind this is an approximation and is appropriate since NP is greater than 10 and N1 minus P is greater than 10. To use the continuity correction factor, we would have to do it this way, using the counts, not the proportions. Yeah, I'm not sure. I think what happened here, I didn't explain myself today. So I set it up for the continuity correction factor. What's the question? Okay, so first I did this. I think what I did, this is a long time ago that I prepared this, but I should let you know that what I did is I solved it with p hat to show you the result with p hat, but that's not how you would use the continuity correction factor. You have to use the continuity correction factor on x. And I think what I started to do here, maybe I didn't finish, is I showed you how to get the same answer if you use, this is how you get the same answer if you use x, right? But this would be the correct answer. So I think I didn't finish. I just didn't finish answering it. So you'd have to do this one to get the right answer. But what did I say? Did I say use the continuity? So yeah, I didn't finish answering the question. Sorry. But you're right. What the heck did I do here? So you would have to do it again. Let me see. I'm going to reproduce this question. It's funny when I do stuff on my computer. One second, I'm here just getting something ready. Because I have to copy. This is the easiest way. Okay, so let's so if you were to do this with a continuity correction factor, you would have to continue, right? So I was just showing, I think I was just trying to show, like I'm repeating myself, that you get the same answer if you use x or p hat, but the continuity correction factor would be better to get an exact result. So you convert this using the CCF into 280.5 because it says do not include 280, so you have to go up. And this one says do not include through 60, so you go down. So this one goes down to 59.5. And then you standardize that. And I don't need to do it. I think I answered your question, right? But there's no answer there, I know. But I don't know. Do you want me to continue? It's okay, Nicole? So it's just sorry. I don't have that solution completed. Okay. Yeah, it's just hard when you see inconsistencies. Okay, so any other questions? Anybody? 2 Moodle exercises for Unit 6 Inf after this. You want me to do those ones? I didn't give you the answers, did I? Let me check. Sorry, so many things happen in a week. I'm sorry, I can't remember. I don't know if I don't think it's aging. I think it's just I have a lot of things going on. And let's see what I gave you. I put them inside SDS. I put them in inf, sorry. I put them in inf. I just wrote them on the screen, I remember. Okay. So I gave you the answers. You can't get the answers? Alec? You need the process? Okay. I wonder if... how I can... Okay, I would like to conduct a hypothesis test at the 5% level to determine whether the true proportion of Canadians who support Prime Minister Justin Trudeau differs from 0.5. Okay, so this is a hypothesis test. So I'm going to do problems in Moodle. So it says that the true proportion of Canadians who support, okay, so it's it's a test of proportion, so you put a P here and a P here, and you write equals. It's always like that. Now you got to figure out the number and the sign you put for the alternative. Remembering that for the null hypothesis is always what is the status quo. What you want to test against is here in the alternative. So if you don't, if the null fails, this is what you believe to be true. Okay, so this is null status quo. And the only number you see in there is 50%, right? So that will be your number. And whatever you put here, you put here. And then differs, the word differs corresponds to not equals. Okay? So n is equal to 300. And 165 of them say that they support. So we're looking for, this is the variable is the support for the Prime Minister. So the number who support is 165, but the sample proportion who support is 165 out of 300. So this is H, and now we do the assume H naught is true. So this is 0.55. So when you look at it, the question is this sample result different enough from the status quo to suggest that, in fact, that's not it, that it's a different value? So what you do first is you assume H naught is true and all of these results fall out. That means that P hat is approximately normally distributed with a mean of P equals to the hypothesized P and a standard deviation of P0, 1 minus P0. So we just get all the results as though the hypothesis and the null hypothesis is true. So when you put all this together, that's what you get. You guys still see the screen on the bottom? Interesting. I don't know why it's showing you that. Let me scroll. Update your screen if what I say doesn't align with what you see. Refresh. Okay. So so you assume H naught is true, and then that's the result of the assumption. That now you have a distribution, even though you don't know anything about P, you have a sample result and you have the theory to count on. So now we do assess the evidence, right? Assess P hat from the sample of 0.55. By standardizing it, you're going to take the sample result minus its mean divided by the standard deviation, or we call it the standard deviation until we put an estimate in there, then it's called standard error, but it's often called standard error. They change the name on you. So we take this is always the sample result minus its hypothesized mean, divide by its standard error, and this is your z-stat. This is a statistic because it comes from the sample. So when you put that together, what do you get? If you have slightly different answers than me, it might be because I'm rounding stuff and you're not, or you're rounding things and I'm not. What I try and do is use consistent rules and I try and use consistent rules and round probabilities to 4 decimal places, okay? So what do you get? I get 1.73, right? So 1.73 now that we have, oops. I've learned how to join these, but it is really annoying. Okay, so assess the evidence, and then what does this mean? This means to us, something not. So that means 1.73 standard deviations is not far from the mean, right? That's not like an outlier in terms of the standard normal distribution. So it looks like 0.55 is not strange or bizarre, not different in the case of the way that we've stated things, but we have to finish answering the question. So we have to get the p-value. The p-value is the probability of seeing a Z statistic as extreme or more extreme than one you got. So what you just do is you take your Z stat and you put the negative here and you put the positive here, and that's all you do. So I'm just going to say make a picture to capture that. So the photo, sorry, the image that you want and what we're testing is that what we're doing is calculating the chance of being as extreme or more extreme, right? As extreme or more extreme. So in other words, what's the chance of being that rare? What's the chance of being that odd? Is it odd? Is really what we're capturing. So now we know how to do this because of the alternative hypothesis. The alternative hypothesis tells us what kind of test to conduct. Not equals, it means check both sides. So you plot the z-stat in two spots. And then you look it up, and what do you get? Now you could use the table or you could use Excel for this. So I recommend using the left side. And you can put negative 1.73. And you say cumulative. And the answer is 0.0418. 0.0418. So this is 0.0418. But also this is 0.418. And what happens is Oh, sorry. Not this way. I have to do this. I wrote it wrong. My apologies. So I did teach you earlier on how to write these when you're looking in the tails. So what you're supposed to write is, let's do this properly. I wrote it wrong. Is that you want I guess you can write it like that, or I'll write it in the reverse because it makes more sense. Make this thing bigger. All right, let me write that again. So the way you write this is you don't have to write it, just draw it. I never write this because I avoid doing this. Not that I don't know how, it's just, it can be confusing and for little value. I want to go outside of the positive and the negative. So I want to go, Z is in the tails. So I believe something like that, right? Let's see, fit it in better. But don't have to write it. So you don't want Z to be between, you want it to be in the tails, you want it to be outside. So it's going to be greater than this amount, but less than the negative version. So this means, this puts it in the tails. If I put the arrow the other way, it goes in between. Okay, so what is this? So now I have the p-value is equal to that area out there, or we write it as equals 2 times Z less than negative 1.73. That's the other way to write that. And so what happens is this number is 2 of those. Which is 0.0836. And finally, the concluding step will use that result and you say if the p-value is less than or equal to, no matter what the alternative hypothesis is, p-value less than or equal to alpha means reject. In our case, p-value, which is 0.0836, is not less than 5% that we're told to use, so we say we fail to reject. Fail to reject means nothing has changed, there's nothing to report, there's nothing new, and the test is considered not significant. and there is insufficient evidence to reject H naught. Any questions? Will alpha always be 0.5? If it doesn't tell you, so there's a bunch of assumptions we made here, right? One is, not that alpha is 0.5 because you're told it, but there's many assumptions laid in what we just did. But yeah, alpha is 0.5 if they don't tell you. Also, if they don't mention it, you assume that this approximation is good. So you're actually assuming that the population is large. And we didn't even check, but n times p should be greater than 10, and n times 1 minus p should be greater than 10. To do this, and I do believe it is because it's 0.5 and 165. So we didn't check these things, but this should be true, this should be true, this should be true. And then the other assumption is using alpha equal to 5%, but it was given in the question, wasn't it? Am I imagining? I think it was given in the question. Yeah. Okay, I was reading it. Okay, so you really need me to do the next one? You want the next one? Oh, I didn't change the title properly. Let me fix that. Get rid of this continued. Okay. Can you also conclude saying that the HA is not 0.5 to reject the null? No, all you can say is, no, you can't say that. You just, everything is focused on the null because that's all we know. All we ever know is the status quo. Any new information has to have some sufficient evidence for it. So, yeah. So how we've termed it is tested on, there's insufficient evidence to reject H naught, and then in words you can say maybe that's what you mean. There is insufficient evidence to say the true proportion is different. Maybe that's what you meant. From 50%. Oh, let me say it even in more words. Let's say of people who support Trudeau is different from 50%. I don't know what his ratings are now in real life, but I hope they're low because he's doing a terrible job. Different from 50%. something like that. It'll just say use level of significance. They'll tell you. So assume the level of significance is 5% unless otherwise indicated. My notes are getting messy, right? I have to slow down. It's tough to write on glass. All right, so did I do the next one? All right. Okay. All right. We would like to estimate the true proportion of Canadians who support Donald Trump. In a random sample of 400 Canadians, 80 of them say they support the American president. Conduct a hypothesis test at the 10% level of significance to determine whether there is evidence that the true proportion of Canadians who support Donald Trump is less than 25%. Okay, so in this one, it's about proportions. So I'm going to write like that. Now, the only number you're told about, okay, you're given a sample result. That doesn't go here, okay? That's really important to note. The sample result doesn't go here. Put them on the side to avoid confusion. So the sample results were that out of n equals 400, 80 support. So this is about supporting. So if you need to remind yourself, the variable of interest is number of people that support Trump out of 400. That's all that X is. It's a sample result. So it's a statistic in that sense. And we are testing for the true proportion. So the other sample result is X over N, which is 80 divided by 400, which is 20%. So that's not the number we use, right? That's the sample result. The number we use is the 25 they mentioned to test against. So they say, the question says less than 0.25. So whatever number you're going to test against, let me put in a different color to let you know this is always the standard setup, and then you have to put the number in here. Okay, so that's we've made the status quo statement that 25% support, it's always an equals here, okay? And then we're going to check if less than 25% support. So we begin with, that's H. So then A is for assume. Assume H naught is true. It means that the sample proportion comes from a distribution of proportions where the mean is, or the expected value is just the hypothesized, because we assumed it's true. And the standard deviation by the theory should be this. So we have to calculate that. So that's 0.25. 0.75 over n, which is 400 square root. And I need a number. I'm going to move this stuff over. So just calculate that while I'm playing over here. So I figured out how to do a lot of things that I like to do. Okay, so let's get that number and put it in the brackets. Okay, 0.0217. So that's true. So now we go to A, assess the evidence. Remember, this spells HAPC. Assess the evidence. What's the evidence? P hat equals X over N equals 20%. So we are comparing this sample result to this as the true one that we hypothesized. So are they different? Clearly they're different. We have to standardize to know how different. How many standard deviations different are these? And then we'll use our statistics tools to say whether it's a strange value. If it's a strange value, then we suspect that something's wrong. But the thing that can be wrong is the assumption that we made, not the actual sample result. We assume that the sample result is accurate. I mean, it's collected properly. Okay? So that's a big assumption. Assess the evidence means we need to standardize this. So we get the Z statistic of taking the sample result and subtracting its mean and dividing its standard deviation, standardizing it into 0.2 minus the results above, 0.25 and 0.0217. And that gives you the result that you want. What do you get? Okay, I get negative 2.30. Okay, so then, again. That's fine. Okay, so then what what we do is draw a picture. Okay, this is for the p-value. The p-value, we draw a picture and we draw our z-stat in the direction of the alternative hypothesis. So we use this now. We haven't used that at all. So we're going to draw our z-stat here, negative 2.3, and we're going to go this way because that's what it's saying. Check to see if it's smaller. So that's the red stuff. Okay, so then looking that up, what do you get? You can go back to Excel. Let's change this number. And you get 0.0107. So this is 0.0107. And finally, that's the p-value. That's the probability. I've converted a z-stat into a probability. I already have my answer here. It tells me I'm 2.3 standard deviations away. And what I have to do is conclude. Always conclude with the statement, so you can memorize the statement and then use it as your foundation for testing the result. So in our case, p-value is 0.0107. We don't do anything else. That's it. We're done. We just check on the left side and we say at the 10%, we're told to test at the 10%. It is smaller than 10%, so we reject H0. Is that true? Is that the answer? Let me see what it did in Moodle. Okay, so it says that if the hypothesis was true, okay, let's finish this and then I'll explain what it says in Moodle. So what we found out is that it is very rare that we found that 2.3 standard deviations away, we found our statistic or the results of the test, or the sampling. So that means 1%, that's just 1% of people approve of Donald Trump, according to these made up numbers. There's no study behind this, I just use these numbers. And that's very strange. It shouldn't be 1%. If it's true that it's about 25%, it wouldn't be that 1% of them supported. I mean, not 1% of them. It wouldn't be that, there's a 1% chance that 20% supported, okay? Because that was the result here. So that's very strange. It's a strange result. So what's wrong? So given the assumption of 25%, it's strange to get 20%. We've translated it into a 1% chance. So we compare that against up to 10%. So we're saying it's we would allow up to 10% chance. Anything smaller than 10% chance of seeing it, and we saw it, would have been considered strange. So it means that something's wrong, so we throw out the assumption. And we can say that there is evidence to suggest, okay, first of all, wait, let me say first, the test is significant. That's the easiest thing to say, and the most important thing to say. Test is, when you reject H0, the test is significant because you found something different from the status quo. So you have something to report. You disproved a hypothesis. You falsified the hypothesis, okay? That's worthy of a report. So that means there is evidence to suggest that less than 25% of Canadians support Trump. Okay. Notice I didn't say anything about the statistic result. I'm going back to the hypothesis. I didn't say there's evidence to suggest that less than 20% of Canadians support Trump. I go back to reading. I repeat the alternative hypothesis. Okay, how's that? Should I teach you new stuff, or is that going to confuse you? You want to stick with the old stuff? I really want to show you how to use the T-table. Okay, so should we just stop, or do you want me to continue going? You want to go study, or you have questions for me? It can be confusing for sure. Right, Gerardo, are you just making a statement? Yeah, this one is less than, so we just checked on the left side. The other one was not equal, so we checked both to see if it's higher or lower. Well, the difference was that we had to multiply by 2. That was the main difference. This 2 here. So in this one, I failed to reject in the first one because it wasn't smaller than 5%. And the other one, I rejected. Okay, so what I did in the conclusion is I said, there is insufficient evidence to say the true proportion of people with is different. So I said there is insufficient evidence to say that. And then here I said there is evidence to suggest that, I could say insufficient or sufficient. I can add the word sufficient here. So there, one is rejecting and one is failing to reject. We never say accept. Well, because if it's 5%, that's okay. We're allowing the threshold of 5% to be a rejection as well. So that's why we let less than or equals. In this case, 10%. If it was 10%, then we would reject. So it's just including the threshold. So you guys like these questions? You did them. Yeah, it's really a little bit frustrating when you're just learning. You're just not sure. You're just not 100%. I remember when I took my final in stats so long ago, and I was so scared and so uncertain. And not until I was done did I believe I knew anything. And then I got 100%, so. But I don't know, sometimes stress is good, sometimes stress is just not good, not healthy. So I don't mean to stress you guys out. I'm just, yeah, I have deadlines. I have to give you grades. If I could be here with you forever, I would. So I hope this is not too messy, what I've written here. I should get back into printing, but when you print, there's too many sounds. Tick, 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 tick. I find it distracting. I prefer to write. Do you want me to do something else? Or are we good? Because I'm not going to teach anything new. We promised. What I could do this week maybe is, well, you guys should work ahead. That's what I'm going to suggest, is that you work ahead, because next week will be the last class before the test. I mean, I could have another session with you. But follow what's called the approximate exam distribution. Follow the approximate exam distribution to know what's on the final, okay? So an STS problem, were you able to do all of them on STS? See if I have it in here still. Sorry. So you have a lot of exercises in here. Were you able to look at the videos in SDS, the control charts? The control limits? I don't know if we have time to do one of those. They're kind of long. Let's look at this. I don't know if this confused you. Let's look at this because I put it here to make you think. Okay, I'm going to pull out the question. Ready? Okay, the age of women with a certain disease is 42 years on average, with a standard deviation of 2. What is the probability that a woman with the disease is over 40 years of age? State any assumption you are making or theorems you're appealing to in order to derive your answer. Okay, so is this a good one? I don't know, Alec, if I answered your question about the p-value less than alpha. So we're trying to say we found a p-value. It's the probability of seeing what we saw in the sample. And the question is that strange? Is it a strange or rare result? And the follow-up question is, what is strange? The 5% or the alpha is setting a threshold for anything smaller than that will be considered very bizarre. Anything that shows up with smaller of a chance, less than a chance of 5% of showing up is going to be considered strange. Okay, and that's when we start saying something's wrong. We're going to reject the assumption, the null hypothesis. Okay, so back to this. What is the probability of a woman? So what I want to do is find the probability that a woman with the disease is over 40 years of age. And I have information here that X is distributed, and I'm not told that it's normal, am I? All I'm told is the mean is 42 and the standard deviation is 2, but I'm not told about the shape. So if you don't know, if you don't know, what are you going to do about this if you don't know the shape? What assumption should I make? Right. You can't do anything, right? We don't know. All we've learned in this class are, in terms of continuous distributions, if you have information on the mean and standard deviation, we know about the normal. I didn't teach you about other distributions. I know the normal, standard normal, the t, and that's it, right? So in order to answer this, you would have to assume x is normal, or even approximately normal, but you can assume it's normal. Then you can solve this. You can turn this into a standard normal and attempt to answer the question. So I want to go to look at greater than 1 on the table or less than -1. So I think I can go to the tables here. I'm going to look at -1, right? Because it's the same, it's because of symmetry, it's the same as on the left as it is on the right. So it's 1587. Right. So for people who are still subtracting, you can check on the right side. Okay, so then this is 15.8% chance. So then that's enough for that. Any questions? So remember, it's about 16% because in between is 68 from 1 standard deviation. And then that means outside is 32. So this is 15.87 on that side and then 15.87 on that side. Makes the 32-ish. Nope. You either do check on the negative or you look up 1 and on +1 you get 0.8413, right? So on +1 you get 0.8413 and then you put that here. And then this is 1 minus . So there's 2 ways to do it. You can look on the negative side, or you can do the 1 minus on the positive side. When you would do, if you did 1 minus, you would be finding this. That's not what you want. You want this. So be clear about what you have. So that's A. Is it okay? Let's look at B. It looks like there's a different answer here. What did I do wrong? We must Oh, that's because it was a negative. I did the math wrong. You're right, Nicole. I did the math wrong. You guys are all confused. Sorry, this is a negative. I did the math wrong. It happens. So you're right. It's not going to be this picture. Let me erase the picture that it's not and do this again. So it's really this one. So I did that wrong. That's a -1. That's why it was wrong. And you were right. So I want to go greater than -1. Since this is on the table, I do 1 minus. Okay. But similarly, you could also check if you change the sign and the direction, you get the same answer. So in this case, what we wanted, let me get my arrows right. We wanted to be greater than, right? But the table only gives us the left side. So I want this, so I look this up, but then I subtract. The other way, if you change the sign and the direction, you get the same answer. So I'm going to change the sign and the direction, and I put a 1 here, and I'll get the same answer. Right. Okay, that's A. Ready for B? Sorry about that. It's a negative. And now are we good with this? Nicole was right. Okay. All right, so in a sample of 100, so let me take this information again. So, so each question I'll state my assumptions. But so far I know this. Mu is 42 and standard deviation, so let's write it. X. Mu is 42 and the standard deviation is 2. Now, in a sample of 100, what is the approximate probability that a woman with a disease is over 40 years of age? Provide a formula that explains your answer. What assumption are you making, or what theorem are you appealing to in order to derive your answer? Well, if X is given with a mean and a standard deviation, but I don't know the shape, if n is greater than or equal to 25, and then I will find that the sample mean is approximately normally distributed with a mean of mu and a standard deviation like this. This is called the central limit theorem. And I can just use the central limit theorem if I care about the sample mean. So let me see what I told you here. So what I said were two different answers. In one case, I said, if you don't use the central limit theorem, then you have to assume normality. And you get this result exactly. Okay, so either you assume normality and you get this result, or you don't assume a normality and you use the central limit theorem. Those are my two answers. So either way gets me to the answer of 100% chance. So if I use a central limit theorem, I'm going to use this result, and I have, since X is unknown unknown distribution, but N is 100, then by the central limit theorem in approximation, oh, I should put the numbers in. So this will be 42, but this new standard deviation will be 2 over square root of 100, which is 2 over 10, or 0.2. So now in approximation, I can solve the chance that somebody in the sample is over 40 years. Now I have to use this new result to standardize. And because of that, I get a negative answer. So the probability of being bigger than -10 is 100%. So the chance of being more than 10 standard deviations below the mean is the whole thing. So this is, if we use a central limit theorem. If you don't use the central limit theorem, you must assume x is normal, or else you can't do this. You can't solve this. And then the results will be the same, because we just write x 42 2. I have to put an n here, and then with n equals 100, it doesn't really matter. We just say x bar is also normal with a mean of 42. So the same results happen. The only difference is that now I'm doing it not as an approximation. It is normal, regardless of the sample size. So Nicole's saying, why is it it's 100? Because I'm going this way. It would be 0 if I went the other way, but I'm looking greater. So that's the whole thing, right? It's 100%. How's that, Nicole? No comments? Yeah, but that's because we were going the other way, Nicole. If I'm going left, no, if I'm going this way, it's 100. But if I'm going the other way, it's 0. There's nothing there. You have to draw it, okay? If you look back, you'll see I'm right. It's just that maybe you didn't see too many like this, so then it's confusing. Okay, so the last one, is there another one? Oops, I do that going out. Is there another part? No. That's it. So I like this because it puts everything together on one page. It looks kind of confusing, but it's only 2 results. You have the result if you have normal distribution, which is this one. And you have the results if you don't. And you use the central limit theorem. That's not very good. Let's do 2 results. And the main thing is, there's nothing here. Because there's nothing here, it makes this an approximation. If there's a shape, then it's normal. Okay, anything else? You want more? More SDS? Don't you guys want to get breakfast? Did you have breakfast already? Let's see. You did the control charts. I made a video on control charts, so. Yeah, you need a break, right? Gerardo's right? You guys agree? So remember, you can use all the resources. You just can't get the help of somebody else. That's the standard for this test. You have the computer videos. You have my notes. You have, you just set up your table with your items organized, sample problems that you've already done, and you understand. And that's the best way to prepare for the test. Let's have things organized for reference. Okay. Let me know if any question isn't clear, and I'll be available. You have until 6 o'clock. If people think they need more time, please private message me and let me know. I'll put my number here. Okay, but it's going to be from 12 to 6. 10 questions from bin, SDS, and proportions of inf. And then next week we're going to focus on the last 2 items of the formula sheet that are related. So work ahead, please. We can also meet before I can do the same thing for the final test, right? or we can meet on the day of the final test as well for a couple of hours. Yeah, work ahead for next week, and watch. Well, read the notes. There are some videos in Moodle, and you can watch the last few videos of lectures from last semester if you want to, where I solve problems. If you really want to hear my voice, but it's very similar. I'm trying to think if I should make you a video this week. And you know what I'll just do is, because my T-table video is damaged. So I need to fix the T-table video in Moodle. So maybe that's what I'll do for you this week, is I will fix the T-table video. I'll make a new one. It's just, I don't know why it's a black screen. So I owe you a T-table video for next week. I'll put it in the chat so I remember. Sorry, Alec. I will update the T-distribution video in Moodle because it is blacked out. I don't know what happened. So can we say all the best? Get organized, have a little bit of breakfast or a little bit of a snack. I'm not sure if you had breakfast already. And breathe deep, and it's going to be okay. You have time. Okay, you have lots of time. So I'm going to say bye for now. Text me if you need me. You're welcome. I have to figure out how to align the live chat with my voice. I don't know how to do that. I have to look into that. Maybe I'll put that on my list as well. All the best. Good luck, everyone.